Hi, welcome to Math for All, where everyone can learn more about math. I'm Mrs. B, and today we're going to continue our study on lines. This time we're talking about linear inequalities. Remember that inequalities are less than, greater than, less than or equal to, and greater than or equal to. Before we jump right in, please go to my website, MathforAll.net, and print out some notes that will help you follow along with this video. You may have seen inequalities before and graphed them on a number line. An example would be x is greater than or equal to 3. A quick recap on that. You put a circle at the 3, color it in because of the or equal to, then put an arrow to the right because that shows all the numbers that are greater than and including 3. We will take examples like that and others and now graph them on the coordinate plane. We'll also graph inequalities that look like this. Y is less than 3x minus 1. That sure looks a little more complex, doesn't it? Before we tackle it, I'll list the steps, then we'll use those steps for a few examples. Step 1, turn the equation into the form y equals mx plus b, our handy-dandy slope-intercept form, if it's not already like that. But keep that inequality sign, no need to turn it into an equal sign. Step 2, start to draw your line the way that you know how to. Plot your y-intercept and then go to the next point with your slope. Don't draw the line through it yet. Step 3, make a decision. If your inequality has less than or greater than, make a dotted line to show that the answer cannot touch your line. If you have a line underneath your inequality indicating or equal to, then you draw a solid line indicating that the points on the line are included in the answer. Step 4, shade the correct section of the graph. If the y is greater than or equal to, you shade above the line where the y's go up to infinity. Logically, if the y is less than or equal to, shade below the line where the y's go to negative infinity. Let's see this in action. Y is greater than 3x minus 1. First up, we notice that if that greater than sign was an equal sign, it would be in the form y equals mx plus b. So we won't touch it. We can get the slope and the y-intercept from this form, so that part's done. Step 2, start our line. The y-intercept is -1. My slope is 3, or 3 over 1. So from my -1, I'll go up 3 and then over 1. Step 3, now to connect those points, I can either do a solid or a dotted line. The greater than with no line underneath says draw a dotted line, so that's what I'm gonna do. Step 4 is to shade. Fun, it's greater than, so shade the y's above the line like this. The y's go to infinity. One thing to note, if you have an inequality in standard form, we could theoretically graph the line using tables or y-intercepts, but I must warn you, don't do that and depend on it for your shading. It can be very deceiving. You should do my first step and turn it into y equals mx plus b so that the shading works amazingly. Take a look at this one. 2x minus y is greater than or equal to 3. Immediately, it looks like we're going to shade above because of that greater than or equal to, but you will not be fooled. We'll follow my steps and see what happens. 1. 2x minus y is greater than or equal to 3. We gotta get that y by itself. Subtract 2x from both sides to get -y is greater than or equal to -2x plus 3. We need to get that negative sign away from the y, so let's divide everything by -1. Remember that rule that we always have a hard time remembering? If we divide an inequality by a negative number, we must flip the inequality. So now we're at y is less than or equal to 2x minus 3. All of those signs change. Step 2, we plot our points. -3, then up 2 over 1. This time we have a solid line because of the or equal to. And finally, we can see that we shade below to -infinity. Beautiful. All of the points in this shaded region and on that solid line make the inequality true. Interestingly enough, we can also graph x is greater than or equal to 3 that we graphed on that number line. We can graph it on the coordinate plane also. 1, it is in the correct form to graph. Step 2, we're going to graph x equals 3, remembering that it's a vertical line at x equals 3. Then we make it solid because of that little line. Step 4, now we're going to shade all of the x's greater than 3, which are to the right. I have way too much fun shading with this program. One last thing that's a little more advanced, but I know you can grasp. We can have 2 or more inequalities that have to be true. Look at this one. Y is greater than -x plus 4, and y is less than or equal to 2x minus 1. Unfortunately, it means double work, but it looks pretty cool. We graph the first line here, dotted, and then shade above it. The second line is here, solid, and shade below it in a different color. The answer is where both of the shadings overlap. That's the answer. You have successfully learned how to solve linear inequalities. To solidify this, please go to my website, MathforAll.net, and get a worksheet to practice some of these on your own using the incredible methods you learned today. Then come back to watch another video and learn even more about math.